Okay, this is just a little update to my previous video where I started machining the fins for the radiator that I'm building for the Sealion, and I'm actually zoomed in on the parts of the Sealion that are completed. I've got the camera in my hand, so it may be a bit jerky, but as you can see, the main body of the engine, the block itself is machined, and the overhead cam drive is also machined and running well. The timing cover with the oil and water pumps, geared pumps, are finished, and they are ready for running the engine when it's completed. That's the water pump, and that's the oil pump. No, wrong way around. That's the water pump. On this side. This is the cylinder head with the overhead camshaft already completed. All the valves are finished, and that's ready for assembly when it's completed. And there's 5 of the cores that I've previously machined for the radiator, with the 2 side frames that will hold everything together, and then of course there will be the header on the top end. That'll be this end probably, and then the bottom end will be attached there, and these side frames will hold everything together, should do, with silver solder or soft solder. So I'm gonna pan round now, and don't look at my workshop too much. I'm really not a very tidy person. There are 3 or 4 more cores. I made a couple spare just in case, so they have to be machined. And now I'm coming round to the lathe. It's a Taig, obviously, and I've attached the Sealion DC motor to drive it, and I also have a tachometer that gives me RPM, and I'll just scan the lathe a little bit so you can see what I've done. Down here I have a 1-inch micrometer attached to a sliding block on dovetails. This bar here has small dovetails on it, and that locks the block up there. The tool post is a tool post that I had on my Drummond, and I liked it so much that I copied it and transferred it over onto the Taig, and it works very well. It's a bit different to the normal type. It has a serrated block here with, I think it's 48 serrations on it, which gives 15-degree movement on each oh boy, my memory's going really bad. So anyway, this here is the new tailstock that I started to develop, and unfortunately it didn't work out exactly as I wanted it. This part here could have been wider to give me more support on the back bar. I found that I was getting movement of probably around about 5 thou, which was moving the center whenever I put any pressure on. So as a result of that, I had to, rather than go completely new with a new design and a lot of work, I decided I'd keep this, and so I used one of the riser blocks on the Taig accessories, and I mounted another aluminium block to support the back end. So now I can tighten this right up. I can put pressure on there and lock it up, and it stays constant. So that works very well. It's not perfect, but I haven't got enough time in my life to worry about making things too perfect. Obviously there's a hole in this block where the quill of the tailstock can move in and out. One of the beauty things about this particular design is that it now allows the saddle to move back underneath the tailstock. I know it's 6 of one and half a dozen of the other. Could have made an ordinary tailstock with a longer reach at the front, but this was an interesting little project that I liked, and so there you are. It works good. I don't have to keep on changing the tool holder over to the other T-slot now to do a complete length between centers. So it serves its purpose, and it's worked out quite well. It's pretty nice and solid. So anyway, I don't know how to pause these blooming cameras, so I'm gonna cool off now, and the next one that you see, I'm gonna set it up on the behind the lathe so that you can see the fins being machined on the cores. The core, by the way, is about, what is it, 4.5 inches? I think it's something like that. 4.5 inches long, and it works out that the fin is 26 thou thick, and the gaps are 40 thou. So the parting off tool is 40. I think it's 43 thou. There's about 60 fins that have to be machined, and of course I can't finish it right off down to the end. So when I get down near the chuck face, then I have to take it out and reverse it and just finish off the odd maybe 5 or 6 fins. But it's a bit fiddly. I found that quite surprised. It's quite a good parting off tool. It wasn't a cheap one, made in USA, but I found that I was quite surprised with the brass dulling the tool after I've done maybe 30 fins, something in that area, 30, maybe 40. And then what happens is you start to put pressure on, and you hear these nasty noises as you have to increase the pressure of the cut, and then all of a sudden it digs in and zoop, like, you get a nasty noise. So it means that I have to take the tool bit out and resharpen it. And what I have there to resharpen it, I only use HSS tool bits. I very seldom use carbide. But what I did do was I built a diamond tool grinder from bits and pieces and parts that I had. The motor is actually 3/4 horsepower, which I had it here, so why not use it? The diamond wheel is 1 inch wide, and it's a diamond wheel that goes onto a particular a diamond grinder, tool grinder, I forget the name of it now, KK something. Really nice. It oscillates and quite expensive, so obviously that's why I built one. But anyway, I think I paid about 180 bucks for the wheel, and it just screws on there. So as you can see, that's how it drives, and it's a 3-to-1 ratio. So the wheel runs at about 70 RPM, I think it is. So it doesn't need any coolant, and it works fairly well with even with HSS. It may not be the right type of diamond wheel, but anyway, that's what I bought, and I'll just switch it on. You can makes a hell of a noise, but it works very well. And the table tilts up and down for rake. So there you can see there's a lot of vibration. So but that's how I grind my tools. I rough them out on the ordinary bench grinder, and then I bring them over here and I just touch them up. And in this particular case, I just take the tool out and I place it on there, and just slide it across a couple of times, and it's resharpened nice and sharp, and it goes back. And then I just have to make sure it's set up diameters and so forth, and square. And so that's that. Not much else I can tell you. I can show you maybe the back of this tailstock system. It's a very similar system to Mr. Let's see, oh boy, Metal Master. I can't remember, David Erwick, Mr. David Erwick.